Okay, we're starting our last lesson over Unit 9, which is geometric probability. Remember that with probability from like 7th and 8th grade, really when you're finding the probability of something to be true, you are just finding what would make it true over, so it's a fraction, the total. Okay, so for example, what is the probability of flipping a heads on a penny? So if I flipped the coin, there's one head, that's what would make it true. There's one head in a coin out of two sides, a total of two. So the probability of flipping a head on a penny would be 1 out of 2. So let's go ahead and look at now how this relates to shapes. Okay, point S on 8, so we're looking for the probability that a point S, it's not on here yet, but if we were to put point S on here, that it would be on the section chosen at random from A to D. What is the probability that point S would be between the points B and C? So what would make it true is if S were between B and C. We don't have a value for it. We don't have a length, but we know the length of BC would make it true over the whole thing. Our whole line is AD. So what would make it true would be if point S was on BC over the whole thing, or the total, which is AD. Okay, let's go ahead and look at it when we're talking about area. This one was length. Now we're looking at area. So point S in a region R is chosen at random. What is the probability that S is in region N? So what is the probability that point S put anywhere in here? So what would make it true would be if it landed in this region or this area. So it would make it true if it landed in the area of N, but that's not the total. The total is R, which is a trapezoid here. So the area of R would be the total. So the probability that point S lands in region N would be area of N divided by area of R. Okay, we have a small definition we're going to fill in here. In geometric probability, outcomes are represented by points on a line. Because that's dealing with length. Or points on a plane, which obviously deals with area. Okay, that is geometric probability, and that's what we're going to be doing today. Okay, so we're going to go ahead and do, this is obviously a ruler, so that makes a line. So this is points on a line, which is dealing with length. A gnat, which is like a little bug or a fly, lands at random on a random point on the edge of the ruler shown below. Find the probability that the point is between 3 and 7 inches. Okay, so first off, how long is a ruler? Obviously, a ruler is 12 inches long. So we want to know what is the probability that it lands between the 3 and the 7. What is the distance from 3 to 7, or the length from 3 to 7? How many inches is 3 inches to 7 inches? We can count 1, 2, 3, 4. So on a 4, out of 12 inches, 4 of them would make this true. So from 3 to 7, that's 4 inches. That's your part that is true. Over the total length, which is 12, that's the part that is the total. Obviously, we want to reduce this. 4 out of 12 reduces to 1/3. So the probability that that bug, oh, that's really ugly, the probability that that bug lands between the numbers 3 and 7 is 1/3 of that ruler. Okay, we're going to save this one for class. Let's go ahead and look at number 2. Okay, now we're dealing with area, okay, because we have a flat surface. Okay, imagine a fly is landing on the diagram below. Find the probability that the fly will land on the red region. Then find the probability that the fly will not land on the red region. Give each answer as a decimal round to the nearest thousandths. Okay, so we're going to need to get out our calculators for this problem. Okay, so the first thing we're going to do is find the probability that the fly lands in the red region. So remember, what is true over the total? Well, in this case, what would make it true is if it landed in the red region. Again, this is an area, so we have to find the area of the red. So obviously red is almost looks like a square, but it's not. It's a rectangle because the length and the width are different. The length is 3, the width is 3.5, or the base is 3, the height is 3.5. Either way, we need to multiply 3 times 3.5 to find the area of the red. So let's go to our calculators. 3, I can get it to work. 3, oh, there it goes. 3 times 3.5. Okay, 10.5 is the area of our red. So that's what would be true, 10.5. So this is 10.5. And then what would be the total? Obviously the whole, all four of our colors together, this giant shape. So this whole length here would be 6. 3 and 3 is 6. 3.5 and 2.5 is 6. So it's a square. So it's a 6 by 6 square. So obviously to find the area of the large whole would be 6 times 6, which is 36. So the area that's true is the red area, 10.5 over, and then the area that's total is 36. So let's go to our calculators and figure out what 10.5 divided by 36 is. Okay, and the question asks us to round to the nearest thousandth, that is 3 decimal places. So 0.291, but the 6 rounds the third decimal place up to a 2. So 0.292 would be the probability that the bug would land on red. Okay, if you wanted to convert this to a percent, if that makes more sense to you, 29.2%, because you just moved the decimal to the right twice. Okay, now we're finding the probability that it does not land on red. Okay, well remember that we did find what red is, and we have the total. So we can take the total and subtract the red to find the area that's not the red. So the total is 36, and we're subtracting red, which is 10.5, which will give us the area that's not red. So 36 minus 10.5 is 25.5. And then again, we're always going to divide it by our total, which is 36. So this is the area that's not red. So the blue, yellow, and green added together, and then divided by 36. Let's see what that is. 25.5 divided by 36. Remember, 3 decimal places because that's a thousandth. 0.708, and the 4 decimal place does not round the 8 up, so 0.708 would be our decimal. Again, if you wanted to make it into a percent, it would be 70.8%. Okay, let's go ahead and look at the back of our notes, and we're going to look at example number 3. Okay, a circle is inscribed in a square. Inscribed just means it's on the inside of the square. Point Q in the square is chosen at random, so a random point inside of our square. What is the probability that Q lies in the shaded region? In this case, our shaded region is our circle. Give your area as a decimal rounded to the nearest thousandth. Okay, so again, what is true over what is total? Well, what is true is if it landed in the circle, because that's what we're looking for. So we're looking for area of the circle, and divided by our total, in this case, would be area of the square. Okay, so first off, let's find area of a circle. We know the area of a circle is pi r squared, so we need to find the radius. Well, we do have the diameter, since 6 is the side length of our square. It's also the same distance from edge to edge of our square, so this is our radius of 6. So that means that if our radius is 6 and our diameter is 6, that means our radius is 3. Okay, so that would make our area 3 squared pi for our circle, and 3 squared is 9. So 9 pi is the area of our circle. And now we divide it by the area of the square. Okay, again, a square is just side times side, and our sides are 6, so it's 6 squared, which is 36. So the area of our square is 36. So we have area of the circle, 9 pi, over area of a square, 36, and we need to divide this and give our answer to the nearest thousandth. Again, 3 decimal places. So go to your calculator. 9 pi divided by 36. And our 3 decimal places are 0.785, and the 3 does not round the 5 up, so 0.785. If you wanted that as a percentage, it would be 78.5%. Okay, we're going to skip 4 and save that for class. Let's look at number 5. Assume that a dart you throw will land on a 1-foot square dartboard and is equally likely to land at any point on the board. Find the probability of hitting each of the blue, yellow, and red regions. The radii of the concentric circles are 1, 2, and 3 inches respectively. Give each answer as a decimal rounded to the nearest thousandth. Okay, for this problem, we're just going to go ahead and find the probability that you get a bullseye, that you land in the blue region, which is the center region. We're not going to do yellow or red. Okay, so again, we want what is true over the total. So in this case, what would make it true, or what would make it what we want, is if it landed in the blue. So we need to find the area of the blue over, and if you look at it, this isn't just a circle, it also can land outside of the circles in the white region, so it's area of the square. Okay, so let's start with finding area of the blue. What does it tell us about the blue? The radii of the concentric circles. Concentric just means they're right in a row. They're inside of each other. Blue is inside of yellow, is inside of red, and the radii are 1, 2, and 3. So the radius of blue would just be 1, and that's the only one we need to know. The radius of blue is 1. Okay, because that will help us find the area of blue, because it's a circle, and we know from the previous problem, pi r squared is area of a circle. We know our radius is 1, so pi times 1 squared. And we know that 1 squared is just 1. So the area of our blue region is just 1 pi, or just pi, divided by area of the square. Okay, well, we have our big square here. Okay, and we see that it's a 12 by 12 inch square, or a 1 foot by 1 foot square. But we're going to keep it in inches. So 12 times 12, or 12 squared, is 144. So the probability that we're going to get a bullseye is 1 pi divided by 144. So let's go ahead and go to our calculators and see the probability of that. 1 pi, or you can just type pi divided by 144, is 0.021. But the 8 here would round the 1 up to a 2. So it's 0.022. Which in reality, if you were to move the decimal over 2 places, that would be 2.2%, that if you threw that dart, that you would make a bullseye. Okay, we're going to go ahead and finish this in class tomorrow. See you guys then.